IT. The cloud this, the cloud that, buzz, 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 cloud, cloud, cloud. But what is the cloud? I mean, what makes it the cloud? If you've been viewing nuggets here at CBT Nuggets on any of the cloud services that are available, Azure or Google Cloud Platform or AWS, then you understand and you're familiar with a lot of the services that you can take advantage of inside of the cloud. But the services don't make the cloud. The services are a product of the cloud. The cloud itself is really a gigantic array of data centers. These are data centers that look just like, at least at a high level, a data center that you might have worked with on-premise at your own local organization. But I can promise you the scale, the scope of these data centers for Microsoft Azure is way beyond anything that you've worked with. Unless, of course, your job is to work at Microsoft Azure on their data centers, then maybe you've worked on them. But otherwise, these data centers support the Microsoft Azure cloud, and they have to be dramatically different. They have to be operated dramatically different in order to support Microsoft Azure. First of all, they're available in 17 different regions. All over the globe, these are all networked together in all these different places. You can get to these data centers from 140 different countries, and you can operate in 10 different languages and 24 currencies. And these data centers not only underlie the Azure services that you and I can use, but they also underlie the Microsoft products and technologies that are available on the internet. So these are the same data centers that are being used to support things like Bing Search and Office 365. Microsoft Xbox, if you use Xbox, their video games run online inside of these Azure GFS data centers. So these data centers have to serve up an enormous volume of data to a wide variety of different products and services to different customers both inside and outside of Microsoft themselves. It's got to do this around the globe in real time with incredibly low latency and incredibly high reliability. If you have any kind of background in infrastructure, that ought to make you go, wow, a little bit. Like, that's a big problem to solve. But the Azure GFS data centers are here to solve that problem. Now, just a little side note, for the purposes of the exam, you may see both the term GFS or the term MCIO, Microsoft Cloud Infrastructure and Operations. They had an internal name change of the department. It's no longer GFS, but depending on what documentation or the exam that you happen to be looking at when those questions or when that documentation was written, you might see either terminology. Just understand that they are completely interchangeable. The first way that Azure GFS data centers are probably different than the data centers you've worked on is just the sheer volume and geographic dispersion of these data centers. You can see here the current list of the 17 regions that Azure offers, and they're all over the globe. They're everywhere. And of course, that's because a data center really represents a physical building, a physical data center where your services can run. And in order to provide the best service to your users, you want to run your services in a data center that's geographically close to them. That'll reduce the latency. So when you spin up a new virtual machine or a web app or an SQL database, you can choose what region you want to run it in. So you want to choose to run it in a region that's going to be close to your primary user base. And of course, don't worry, if your users are all over the globe, Azure provides ways to share your system across multiple different regions so that you can ensure that your users always have access to a data center that's relatively close to them, reducing the latency, improving the performance and the reliability of your product, a win-win across the board. Now, it's important to note that Azure is also available in China, but it's kind of separate and distinct from the rest of this. It's provided by a third-party ISP, so the data center does not share data in and outside of China. But if you need to run Azure in China, you can do that as well. Now, all of these regions, all of these data centers are not actually the same. The services that you can get vary by region. And I've just clipped a little picture of the diagram here, but if you go to this URL, and I'll bring it right up on screen, you can actually see the services that are available per region. Down the left-hand side is each service. So if you want, let's say, D-Series, you can see that you can get D-Series in all of these different eastern US locations, but not in these government locations in Virginia, for instance. So as you scroll down here, you've got all your different services down the left. Across the top, you have your different regions. You can see what services are going to be available in what region. Another way that GFS data centers are different than yours, well, Azure data centers are big. Some are as large as 3 cruise ships packed end to end, and they're just spilling over with servers. They have more servers than you can count stacked inside of them. And that introduces some unique complexities, some unique challenges that Azure data centers have to deal with. For one, hardware failures become the day-to-day norm. Because you have so many servers, you're going to frequently and often have servers that are failing, drives that are failing, equipment, power supplies, etc. that is failing. In a typical data center, what you're concerned with is your mean time between failures. You want to reduce the amount of times that you have a failure, and you want to make sure and keep your uptime as close to 100% as possible. But when you're dealing with this many servers and so many expectations of failure, What you're more interested in is your mean time to recover. You want your services that are running on a piece of equipment that might fail to quickly and seamlessly migrate over to some clean running equipment. They use something called commodity servers for this, which means that they are less likely to stay up and be reliable, but they're cheaper and easier to move services around between them. So inside of an Azure GFS data center, your mean time to recover, MTTR, becomes much more important than your mean time between failures, your MTBF. And this is unique, or at least a little bit different than your typical data center. Now, in order for this to happen, your workload migration, as much as possible, must be automated. You can't count on people to pick up and move things, services, drives, physical equipment, etc., between different servers. It's all got to happen in an automated fashion. Software has to migrate off of bad equipment and onto functional equipment. And that's a big part of what makes Azure so impressive, is the software layer that runs on top of this infrastructure that keeps things running smoothly, that makes everything appear reliable, even though underneath is very tumultuous and there may be failures and things going wrong all the time. You and I, as users of Azure, we don't really see that. Another thing to understand about GFS data centers is that security is the highest priority operation inside of any data center. Think about it. This data center has got my data. It's got your data. It's got Microsoft's data. It's got 1,000 other customers' data all inside of this great big equipment-filled room. And that makes it a juicy target for cyber threats as well as physical threats. Microsoft takes great care to ensure that the data centers are as secure as they can possibly make them. And this happens at a couple of different levels. First of all, the staff themselves, Microsoft staff, is carefully monitored to ensure that they don't inappropriately access the data or the information that's contained inside of those services. Physical security, of course, is provided, keep people from wandering into the data center that aren't allowed to be there. And threat management, software threat management, is provided so as a base level of protection for all of your services that are running inside of the data center. So you can ensure that they are already, before information requests, etc., even get to your virtual machine, even get to your web application, it's being scrubbed and monitored for potential threats. You can read all about this and more at the Trust Center security page that I've just linked right here. This is a good URL if you need to understand exactly how secure the GFS data centers are, and you should want to go ahead and check that out, by the way, because security should be a big priority for us as well as for Microsoft. Now, like I said, Azure data centers are really good at moving your services around off of failed hardware, but sometimes failures are more systemic or widespread than a single piece of hardware. And for that, we have update and fault domains. Update and fault domains are groups of machines, instances inside of Azure that are separate and distinct from one another, usually on separate racks, separate power supplies, separate cooling systems, etc. And the reason for that is because when you have a widespread outage, either planned or unplanned, you know that at least you have some services running on a different system and are probably not affected by that outage. So update domains are for planned updates to the service. Say they have to roll out a big update to the Microsoft Azure infrastructure software. Well, if all your machines were running on the infrastructure that was being updated, you would have an outage. But as long as you spread your machines, your instances, across update domains, well, they'll only ever update one domain at one time, so the machines that are running in the second update domain won't get updated. Fault domains work exactly the same, but they're for unplanned outages. Let's say the power goes out to an entire row of racks at a data center. I mean, these things happen. They're, ultimately run by people, and problems happen. Well, as long as you have your machines spread across different fault domains, you know that you have a whole set of machines on a different row of racks that are probably not affected by this outage. The likelihood of a problem happening across two different fault domains is very, very low. In fact, if it happens across two fault domains, probably the entire region is out, and at that point you need cross-region replication. All you need to do to enable update and fault domains is simply have two or more virtual machines in an availability set. It's really easy to use. You don't have to do anything other than create the availability set and then add your virtual machines to it. When you do that, they get automatically spread across these different domains, and as long as you have two or more VMs in that availability set, you qualify for 99.99% uptime SLA. So as long as you have more than one machine in your set, they will get spread across multiple update and multiple fault domains, and we'll talk more in depth about that in a different nugget, and that will get you your 99.99% uptime. Now, I just mentioned, of course, the possibility that you have a region-wide outage, maybe a natural disaster takes out an entire data center, and in order to deal with that, your fault and update domains are not enough. you need to make sure that you have cross-region replication set up. So for your really important high priority production systems, you can set up cross-region replication, which exactly what it sounds like is just going to replicate your information to a secondary region. You choose the primary region where your services are going to run from and your users are going to access, and if for whatever reason that region goes down, that primary region is lost, well, the system automatically fails over to the secondary region. Your users are not afflicted by the outage. They're simply accessing the data, accessing the services from the secondary region. Again, what's nice about this is once you set up the replication, once you've set up the cross-region backups, you don't have to do anything to fail over. In the event that there's a problem in the primary region, the secondary region will automatically spin up. It's like a hot backup, will automatically spin up and start getting used by your users. They might see a little bit slower service because that secondary region is not as close to them as the primary region, but at least they won't be down, they won't be affected by the outage. Now, the last thing that you may see or you may have to deal with inside of a GFS data center is service throttling. And this is to ensure consistent delivery, not just to you, but to every customer, every client inside of the data center. Because it's a shared system, a shared data center, they need to throttle service and impose some quotas on how much you can use in order